Now we will multiply some rational expressions. When we're multiplying rational expressions, the whole idea, again, is to factor every expression as much as we can and then cancel like factors. You really don't want to be multiplying everything all across if you don't have to. So the first thing I'll do here is I can see that I have a common factor of 8. So I would factor an 8 out of each of these to the top. So this would really be 8 parentheses p minus 1, because 8 times p is 8p, and 8 times negative 1 is negative 8. And then I would factor this expression down here. I'd factor a 9 out of here, and that would get me 9 parentheses that same p minus 1. So because I had a p minus 1 factored up here, I was looking for that to appear down here. Now I have a p minus 1 and a p minus 1. And again, we can always extend our line here and realize that when we are multiplying two fractions, it's really like multiplying everything here times everything here. So I'm going to take a p minus 1 divided by p minus 1, and that's going to give me 1. And now I have a p, and I have a p squared rather divided by a p. So this is two factors of p, and this is one factor of p. So 2 minus 1. When we divide exponents of the same base, we keep the base and we subtract the exponents. So this would really be 8 times 7 times p divided by 9, because this one of the p's here and this p would cancel. So 8 times 7 is 56, so that would be 56p divided by 9. Do 9 and 56 share any common factors? It's 8 times 7. They do not. So 56p divided by 9 is the simplified answer to this. So again, we factored the binomials first and then canceled out like factors between the p's and the binomials until this is all we were left with. Same thing here. Don't think that you have to multiply a trinomial times a trinomial and then divide by another said multiplication. We're going to factor each of these four expressions first. We have a coefficient of 1 on each of these x's, so we're really looking for a pattern such as this for each of them. So let's let the structure become apparent to us when we're practicing these. So we are looking for this. If we have a coefficient of 1 here, and we have an x term in the middle, so second power, single x coefficient, no x, we're going to have this structure to fill in. So now we're looking for two numbers that multiply to 1 times 10 and add to negative 11. So multiply to positive 10 and add to negative 11. Well, that's going to be negative 10 and negative 1, because negative 10 times negative 1 is positive 10, and negative 10 plus negative 1 is negative 11. So we factored this piece. Now we'll factor the one below it. Two numbers that multiply to 1 times 28 and add to negative 11. So that's going to be negative 7 and negative 4, because negative 7 times negative 4 is positive 1 times 28, and negative 7 plus negative 4 is negative 11. Now, take a look over here. None of these were able to cancel here, but because I'm being asked to multiply two of these, I would expect there to be some canceling happening later. So look for some of these factors to appear up in here. So I'm looking for the product of 1 times 20 that multiplies to negative 9. So two numbers that multiply to positive 20 and add to negative 9. That's going to be minus 5 and minus 4, because negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. And I can see that the x minus 4 and this x minus 4 over here are going to eventually cancel. Down here, two numbers that multiply to 1 times 60 and add to 16. That's negative. So 10 times 6 is 60, but they add to positive 16, so negative 10 and negative 6. They multiply to positive 60, they add to negative 16. Now, because I'm multiplying two fractions together, I can extend the fraction bar and really just be multiplying everything. And now that gives me the license to look for common factors. I have an x minus 10 up here and an x minus 10 down here, so they can cancel because each of them divided by the other is 1. I also have an x minus 4 and an x minus 4, so one in the numerator and one in the denominator. Now all I'm left with are terms that cannot cancel, so I just need to rewrite them. I have x minus 1 times x minus 5 over x minus 7 times x minus 6. Some students will go further and FOIL these in order to turn them back into trinomials, but you don't have to do that. Whenever you're asked to do these, you can just factor every expression that you have and then cancel like factors and leave your answer as being shown as a product of factors instead of having to multiply those factors into the polynomial. You don't have to do that.